Today, lesson 24A, more on the idea of functions. In fact, today we sort of tie the whole idea together where we are piecing in all of the things we've been doing over the last 3 days. So today, you'll be able to determine whether one thing is a function of another and defining in full detail dependent and independent variables. And we'll be able to verbally justify why a situation may or may not be a function. Okay, so one of the things we've talked about in this unit so far, determining if something is a function based on a mapping. Mappings are like number 1 and number 4, or maybe like from a table like in number 2, or from a graph. Obviously, number 1 is the only one that is a function up there. Number 2 and, number 2 and 4 are not, because there's not a unique input or a unique output for each input. Number 3 is not a function because of the vertical line test. We've also talked about how to find a function rule from a table or from a graph, which is what we talked about yesterday. And remember, the equation of that line and the function rule are really representing exactly the same thing. And going back to some of these other things when I talked about definitions, you need to realize that all of these things are representing the same thing, and all of these things are representing the same thing. And today we're going to go in a little more detail on dependent and independent variable. All right, so let's take a look at number 1. You go fishing and you catch 3 fish each hour. So here we have a table, and in that table I have some X values for the number of hours spent fishing. I would like you to finish filling out that table. Remember, you go fishing and you catch 3 fish each hour, so you should be able to easily finish off the table. And then I want you to take those ordered pairs, and then I would like you to plot them on the coordinate plane. All right, as we're finishing this one up, if you went fishing for 3 hours, you caught 9 fish because you're catching 3 fish each hour. For 2 hours, 6 fish. 1 hour, 3 fish. 2 hours, 6 fish. 0 hours, obviously 0 fish. And 4 hours, 12 fish. And if we plot all of those, by the way, is this a proportional relationship?
Yes.
Yes, it is. It's linear, goes through the origin. What would the function rule be for this situation? It would be y equals 3x, and that's another proof that this is a proportional relationship. Based on your knowledge of functions, does this represent a function, yes or no? Yes. Yes, it does. Okay? So I would like you to write this statement down below your table and graph. The number of fish caught is a function of the number of hours spent fishing. All right, I have several more questions to ask you regarding this problem here. We already talked about that is the function rule, and we already talked about that this is a proportional relationship. But which variable is the dependent variable, and which one is the independent variable? Remember, the dependent variable depends on what the independent variable is doing. Which one is which? There you go. And so that would make the independent variable x. And the dependent variable is y in this one because the number of fish that you catch depends on how many hours that you have fished. Now, there's one thing that we also have to talk about, and that is this. I noticed that some of you, out of habit, you connected all of your dots together. You drew a straight line through there. And so my next question is this: should the dots be connected? Well, before you answer that question, here's what you have to think about. And that is this. If you think dots should be connected, then you're saying that, well, here at a half, that would be okay. Because if you're connecting them together, then you're saying all of these points in between would make sense. So here's what you're saying. You're saying, well, maybe at half an hour, I caught right here, which would be 1.5 fish. Does that make any sense? Yes or no? No. And so in this situation, connecting them together doesn't make any sense. And so that brings up two new definitions. These will not be on the quiz tomorrow. And that is that of a discrete relation. And something is discrete, basically, if it doesn't make any sense to connect the dots together. And another example would be like if I were plotting the number of students in this class. It doesn't make any sense to plot half of a student, so that would be an example of a discrete situation. A situation where it does make sense to connect them all together, that's called a continuous relation. So we have to think about those things before we start connecting our dots together. So if you did do that, erase it. The dots should not be connected together in a line in this one. Okay, so the dots should not be connected. All right, let's go to number 2. This time, your best friend goes fishing, and what happened when he went fishing is all within the table. I would like you to plot those ordered pairs, and then I have some questions based on what that looks like. So I'll give you about a minute or so to get that finished. As you're finishing this one up, so far, and I believe in all of the questions today in the notes, I went ahead and I have labeled the x-axis and the y-axis, and it should be obvious how those are labeled. X represents, in this problem, the number of hours spent fishing, so that's why the label is down there, and y represents the number of fish caught, so that's why the label is there. And in the homework, there are some problems where there aren't any labels there. You will need to make sure that you label your x-axis and your y-axis. Okay, let me go ahead and plot these. So there's 1, 4, 1 hour spent fishing, 4 fish caught, and so on. My question is this a function, yes or no? No. So what tells you that it is not a function?
Because 2 different points end on 5.
Okay, yeah, or the vertical line test, right? Okay, so this is definitely not a function, and you don't need to write down the sentence this time. All right, let's go to number 3. The table below shows the number of nickels you put into a machine and the number of gumballs you received. Could I get all of you to plot those? I'm going to ask you the same questions that I've asked in the other problems. Is it a function? If it's a proportional relationship, if it's discrete or continuous. So keep those things in mind as you are plotting all of the data there. Let me quickly plot all of these. And I'm not sure whether I have these plotted or not in the lesson. I think I do. Yeah, I do. Okay. While I'm doing this, is this a function, yes or no? Yes, yes it is. Is it a proportional relationship? Yes. Yeah, because if you don't put any nickels in the machine, you are not going to receive any gumballs. There's 0, 0. There's the origin. What's the function rule?
Y equals 2.
Okay. Discrete or continuous? Continuous. Really? All right. Hold on a second there. Hold that thought. Hold on a second. You're telling me that I can put half of a nickel in that machine. If I put half a nickel, that would give me 1 gumball. I can't put half a nickel in that machine. Therefore, it is discrete. We are not going to connect those together. And so one other question just came up, and it was regarding, what number was that? 1?
Number 1 and 2.
Number 1 and 2. The question was, how can number 1 be a function when we had 2, 6, 2, 6? And the same question, well, a similar question came up first period, and somebody thought they had it figured out, because I think maybe somebody told them last year that if you see a repeat in the domain, it's not a function. And you have to be careful with that. The definition for a function regarding ordered pairs is each x value has 1 unique y value. But when you have 2, 6 and 2, 6, it does have a unique y value. When x is 2, y is 6, right? That's different than if you had 2, 6 and 2, 5, because then each x value would not have a unique y value. The value of x would have 2 different y values. So does that answer your question? Yeah, you can't just look at the domain and think that when you see two of the same number, you have to be careful with that.
So on number 2, since there's 2 3s, they both have different y values.
It's not because there's 2 3s, it's because they have different y values. That's the reason why. Okay? Is that cleared up? Okay. All right. So this one is finished. We already answered that, we already answered that, and we already answered that. And obviously the number of nickels are the independent variables, and the dependent variables are the number of gumballs. Okay. Here we have a different one. Now, the next few problems, my hope is that we can deal with these without filling in everything. Okay? Sometimes it's necessary to take that data, fill in the chart, maybe come up with an equation, but sometimes it is not. And most of the rest of the problems deal with that idea. So the question here is going to be this. Is this a function?
No.
Really? Plot the ordered pairs. All right, so now we have that cleared up here. Every single time you put in one nickel, you get a different number of gumballs. This ends up being a vertical, they line up vertically, and because of the definition of a function, this is not. And you might want to write that in there because there seems to be, I keep throwing these vertical and horizontal line problems on homework, and some of us still don't have that down, but if we did connect those together, it would be x equals 1. All right, number 5. The graph represents data from the diameter of a cookie, of a chocolate chip cookie, and the number of chocolate chips in there. The main question here is this. I could make all of you fill in the table from the data there, from the ordered pairs, but the end question is this. Is this a function? Yes or no? No, and you don't have to look very hard to see that it is not a function. And that's why in the rest of the problems I put use the table if needed or use the graph if needed. This is not a function. Okay, and because of the vertical line test. Here it says, and we need to change, we have a little bit of a typo there in your notes. Can you change the equation to y equals 4x? The number of tires y in the parking lot at Chris's Cars is modeled by the equation y equals 4x, where x is the number of cars in the lot. Now, we have some choices here. I could go ahead and have you fill in the chart. 1 car, 4 tires. 2 cars, 8 tires. So on. And I could have you plot that data. But what I want you to do right now is turn to your shoulder partner and discuss why or why not as far as whether this is a function or not. It's a function. Okay? And this is what gives it away right there. All right. Number 7. The cost for cars entering a toll booth is based on how many passengers are found in the car and is listed in the table below. Of course, the question that I'm about to ask you is whether it is a function or not. Figure that out, and then we'll have you discuss that with your shoulder partner. All right, so there's a reason why this one is the last one as far as this type of problem for today. And I think a few of you weren't sure and you shied away from graphing because you knew you couldn't fit some of those ordered pairs on the graph. And there is one in the homework where you're going to have to change the scale. Down here on the x-axis, you can just go by ones because you only have to plot 1 through 5. But here's where the problem is, because I think going up the y-axis, it only goes up to 15. So anytime you're in a situation like that, and you may have already dealt with this in science, I'm not sure, but sometimes you have to change the scale. And so when you do that, as far as up the y-axis, you probably could get away with going by 2s. And what I don't want you to think is that the scale for x-axis and y-axis have to be the same. They do not have to be the same. So if I'm doing this problem and I feel like I need to plot the data there, I would go by 1s here and 2s right there. And keep that in mind with one of the homework problems. Yes?
On our homework, do you want us to graph, or is it like mandatory? Or?
You do what you need to do to answer the question. I'll leave it at that.
So we're not going to get it wrong.
No, you do what you need to do to answer the question. Okay? And I guess we need to get to the question here. Is this is this a function? Yes or no?
Yes.
Yes, it is. And is it a proportional relationship?
No.
Okay. All right, so our last thing for today is taking something in words and figuring out what the independent variable is, or what part of the problem represents an independent variable, and the same thing with a dependent variable. So we're going to do number 8 together, and then I'll have you do number 9 and 10, and then we are finished for the day. So number 8, the math club is selling tickets to the math Super Bowl. The more tickets they sell increases the amount of money they can spend on beverages and food. So we've got two situations there. Money coming in and selling tickets. Which one of those is the dependent variable? Yes?
The dependent variable is the amount of food and beverages you can buy.
The amount of what?
Food and beverages.
Well, in order to do that, you have to get money. So are you talking about the amount of money that comes in? Okay. Yeah, the amount of money earned comes from or depends on the number of tickets sold. So money earned, dependent variable. Number of tickets sold, independent variable. Go ahead and quickly do number 9 and number 10, and then we'll exchange with our shoulder partner. Tickets sold. In number 9, it says the number of calories you burn increases as the number of minutes that you walk increases. So the number of calories burned, that's the dependent variable. It depends on the number of minutes that you walked. And number 10, as the amount of rain decreases, so does the level of the water. Water level depends on the amount of rain. All right, we are finished.